Today's lecture, or this lecture, I don't think I do these one a day. I do a lot more than that. But nonetheless, I want to look at limits where x is going to infinity. I think I've taken care of pretty much all the other possible cases that can happen. But this last one is filled with a lot of adventure. Let me start with the simplest function that you can think of when we talk about these limits as x goes to infinity. I want you to think about the function y equals 1 over x. As usual, let me get a graph of it. Go into the y equals. Please clear whatever is in there. And as usual, into y1, I'll put 1 divided by x. And as usual, I'll do zoom 6 just to get a quick graph to see what I'm dealing with. It's difficult to see, very small from this picture, so let me zoom in a little bit. I think what I'll do is go from -5 to 5 for the x min and x max, and -5 to 5 for y min and y max. And now go ahead and graph. There we go. So it seems I can see a little better here. Let me take a look. Well, let's grab this first. Paste it in, stretch it out. Good. While I'm at it, I might as well just remind you of what the limits are as x goes to 0. If you look at x going to 0 from the left of 0, so 0 to the negative of 1 over x, that is negative infinity. The graph goes down. The limit as x goes to 0 from the positive side, 1 over x equals positive infinity. Therefore, the limit as x goes to 0 of 1 over x does not exist. So that has nothing to do with what I want to do here. Just, well, actually, I don't want to say that. The relationship between 0 and infinity is a very interesting one, and this graph seems to have it all in one. Because as I go to 0, 1 over x is going to infinity or negative infinity. But now if I go to 0, if I let x go to infinity, let's take a look at some values. See where I want to go. Let's trace. You can hold down the right arrow button and it will show you the trace. What you're getting is the trace values. You can see I'm going 0.14, 0.13, but it's not exactly what I call fast. When I say go to infinity, I'm talking huge numbers here, bigger numbers than you've ever probably could imagine. But nonetheless, I'll start at 9,999 and I'll increment by 10,000. Let's take a look at the table and tell me what we get. Look at those numbers under y1. Remember that e-4, e-5 means that you move the decimal to the left 4 or 5, or in this case 6 places when you see e-6. So all of these numbers are very, very small. The one I stopped on here is 0.000003, for example. What this tells me, if I keep going, I'll get 0. Now, it will never actually equal 0. It will just get closer and closer and closer to 0. Now, while I'm here, let me look at the other side. That's as x goes to negative infinity. So I'll put -9999. And I have to increment by a negative amount too. So basically I'm playing the same game except I'm doing negatives. Now let's take a look at the table values again. Move over. And once again, these are tiny. These are negative numbers, but they're all really tiny. Here we have e-6. That's the same. So I'm getting the same thing, except it's going to go to 0 through negative values. In fact, either one of these two limits that I just wrote there is enough to show that there is a horizontal asymptote to the function. In fact, the y equals 0 is a horizontal asymptote. And this will happen anytime you have a limit as x goes to infinity approaches any kind of a number. You're going to get a horizontal asymptote. Let's do an example. This time I want to pick a more complicated rational function. So we have 3x cubed minus x plus 1 over, lucky for control Z, comes to my aid. So I'm going to have that over 7x cubed plus x squared minus 3x plus 5. Let's go ahead and throw this in the calculator and see if I can do the same kind of stuff as I did before. Let's clear out what we have in there. Remember, you need to use parentheses in the numerator and the denominator. So let me get my 3x to the third. Don't forget to come out of the exponent. Minus x plus 1. End the parenthesis. Divide. Now start a new parenthesis. 7x cubed, come down off of that, plus x squared minus 3x plus 5. Finish the parenthesis. So let's take a look. Zoom 6 as usual. Let's see what this does for me. Honestly, that graph doesn't do a lot for me. The numbers are just small, or at least the graph is very close to the x-axis. Let me zoom in just a little bit here. There we go. Okay. I can see there's a vertical asymptote in there somewhere. And I can see that the graph does level off as you go off to the right. I want to do the same thing as before. I'm going to go into the table and put in my values. So I'll start at 9,999. And I'll increment by 10,000. And if you go over into the y equals column, there's a negative 0.5. Oh, the numbers on the left tell me I did my incrementing wrong. Go back to table set. I need to take that negative out of there. Get that out of there and just delete it. We have a button for that. Good. Now let me go back to the table again. So let's go over to the right. And you can see the decimals. I got 0.42857 isn't changing the whole time. All it's doing is filling out decimals after that. So I'm convinced after doing enough of this that to 3 decimal places I can write 0.429. Now, a little more analysis I think you should do. I'm going to show you a program here. By the way, it's a free download. If you want to use this program called Graph that I'm using, it's absolutely free. I think it's one of those sites that they would like it if you donate or something like that, but there's under no pressure to do so. In my syllabus, I list this as a resource for you if you want to download it. It does better graphs than the calculator. And it's not the only free graphing thing available for the computer. There's tons of them out there. You just have to search for them. So let me get all this stuff in. Finish the parenthesis. And sort of like before, it's... Now this is a better looking graph. Right off the bat, it's better looking than what the calculator did for me. But nonetheless, I want to zoom in a little bit. No, I don't want to change. I want the x values are fine. Keep them the same. I'll start from -10 to 10 for the x values. And then the y values, that's what I wanted to change from -5 to 5. Let's take a look at this graph. Well, but what it highlights is this. I'm going to now graph alongside with it the line y equals 0.429. Horizontal line. Change the color to an annoying shade of red so it's clear what happens there. Do you see how the line molds to the graph? Now, the graph makes it look like they touch. Whether they do or not is something for a later date. Right now, I can see that that is quite clearly close to a horizontal asymptote for this function. So, later in the course also, we will be able to determine this line exactly. But for right now, we'll just go with the decimal approximation. All right, that'll be it for this particular program. I'll go on and do more examples of this type in the next videos.